Well, today we are very lucky to have Amit Zoran with us from MIT. Amit is a PhD student in Responsive Environments Group at MIT's Media Lab, currently in his final year. Hooray! He holds a master's degree in product design from Bezalel, the Israeli Academy of Art and Design in Jerusalem, a Bachelor of Science in Communication Systems Engineering from Ben Gurion University in Israel. Specializing in digital signal processing, Amit previously worked as an image and audio processing engineer for companies in the Israeli high-tech industry on a variety of real-time DSP projects. So we're excited to have you here. Thank you for coming, and we look forward to hearing what you have to say.
Thank you. Thank you very much for inviting me. I'm very excited to be here. What I will mostly present today is my PhD, which I call Hybrid Reassemblage. I'm not sure about the name yet, but before I will start digging into my current research, I would like to introduce a little bit what is my background and where I'm coming from. So, yes, I come from DSP and I worked 6 years in developing image and signal processing algorithms. But I always had this passion for tangible and aesthetic type of creation. So I decided to go a little bit to the direction of product design. And my first investigation in design field, and it's a passion that I still have, is about conceptualizing futuristic ideas, while further than making practical working technologies side by side to my engineer work. I'm all the time trying to throw the ball ahead and doing rendering and try to visualize ideas. But in the same time, I have a passion for tangible type of experience, for craft, for material. And this triangular, the tangible experience of physical material, the visualization of futuristic concept, and my engineering background is what I'm all the time trying to seek for a synergy, that all those corners will work together. And this is kind of the thing that I'm trying to do since my first days in the MIT Media Lab, which was like 5.5 years ago. So I will start with some background of my work in the Media Lab, things that are preliminary to my current research. And as a lot of people in the lab and in other places, I was, and I'm still, very excited of the promise of digital design and digital fabrication. The possibility that the digital tools opened for us in a manifestation of physical work. For example, in this conceptual trumpet, you see multiple pipes, one inside the other. This is something that you cannot make in traditional craft. In the techniques that they are bending pipes, you cannot bend multiple pipes, but you can 3D print it easily. And in order to test and to visualize what digital fabrication can actually do, I started with a project called 3D Printed Flute. It's a project that I did like 2.5 or 3 years ago of a fully functional 3D printed flute when it was printed with all the mechanics on object codecs printer. We are speaking about 9 hours of print to have this section of the flute with the mechanics already assembled. The only thing that I needed to add later are springs, and then it worked. So this is not a very good flute, and I'm not trying to say that the future of flute is depend on digital fabrication, but this is a demonstration of printing something functional. And in this type of investigation, I also played a little bit with some idea of using digital fabrication technologies for cooking. So, okay, this is a recipe of a lasagna divided to different functionalities. So we are taking different ingredients, then we combine them, transfer them from one state to another by heating, then doing mixing and combination, transforming again. At the end, we have like modeling in several places, we give them a shape, and so on. So I decided together with a friend to visualize some ideas of how a machine that can do this type of operation can look like. So this is just a concept design, just rendering. Here you have a digital mixer, a carousel of different ingredients that can move controlled by a computer, and then at the same time on the fly, you can test different combination of the same recipe. This is a 3D printer idea. Different containers. Each container has ingredients in controlled viscosity, and you can apply it on a tray inside the chamber, which behave as an oven also. This is just a conceptual work, but this is kind of the place that I'm coming from when I'm starting to speak about my current work. And my current work take a little bit different approach or different tradition, considering totally different type of approach to material and to tangibility. And we're speaking about craft. Unlike the abstractization and reductionism that we have in digital environment when we work on the computer and then we outsource the process of making to the machine, in craft, the experience is everything about being involved and being engaged and touching. And each day you're a bit different, each day you get a different result. And this quality of things that are not predefined or predetermined is something that I'm seeking and I'm looking to introduce to my work in digital environment. There is one specific definition of craft which I like by David Pye. And again, craft is not what is important. What is important are those qualities. Quality of result that is not predetermined, of involvement, and of intimate engagement in order to create a final artifact in a process that is a process of risk-taking. Each day you're doing something, you don't have a machine or a computer that will guarantee a result, and each day something else will happen, but this is part of life, this is reality. And this is, I believe, part of the thing that I'm seeking in as a bigger tradition, which happened to be very popular, the DIY movement. Many people have this passion to take your hand and to push them and to make things and to assemble things and to be involved in the making process. And it's not always about the final result that will be better. It's not always about making it better or making it faster or making it more efficient. It's being involved. I like to, this is a friend of a friend that decided with his father to build an airplane in the garage at home. I like this story because this airplane cost them twice the cost of buying the same airplane and took them 6 years to complete. And when I interviewed him, I said, why are you doing it? I mean, it makes no sense. And he said, yeah, but it's, you know, we like to do it. It's my opportunity to work with my father and to be engaged in this process. He's an engineer the rest of the week. And this type of quality, which is actually not very different than totally other tradition. This is Junshai maker, hunter-gatherer in Southern Africa, that making hunting bow, that is in a technique that he studies from his father. And I met them and I did some work with them in an interview, and I'm getting similar type of answers. So trying to say this is a cross-discipline, cross-culture passion to make things and to be involved. And this is what led me into my current work. And to make it more precise, what I'm seeking, what I'm searching in my work is maybe to ask if it's possible in digital realm and digital environment to reclaim a lost material identity in our cyberspace of design and fabrication. I hope it's possible, and I hope to make it clearer by 3 projects. So this project together are what I call hybrid reassembly. This is my main research right now. The first project is the 3D. It's a tool that I will explain what it's doing. Then I have a guitar that I completed several years ago. And a fused craft is a collection of artifacts. It's a side project that I'm working on. The first 2 are more interactive projects. This is more traditional HCI. The last one is a design. There is no interaction here. Yeah, but I hope you will like it. So I'm starting with the 3D. I'm a designer, and I like to fabricate a lot of things that I'm making. But I also like to be involved. However, I don't have a skill as a sculptor. I cannot take a chisel or a Dremel and do something. I need a computer to do it. But I want to do it. I have 2 options. To invest 5, 10 years to learn traditional carving. Hopefully I will have this time. Right now I don't have it. Another one is to ask the computer to help me, to assist me in such a process. So I developed this tool. This is like a Dremel tool. It's a handheld device. You hold it by hand. This is how it looks when it's open. So what we have here we have a milling bit. Here we have a motor controlling the milling bit. Here we have 3 servo motors and a special bearing mechanism. When each of the servo moves, all the handle can rotate, meaning the tool can change its position in my hand. I'm holding it, and it can move like that, back and forth, or with an angle. So 3 degrees of freedom. Here, I have a magnetic sensor. tracking sensor by Polhimas. So the tool knows the exact location in space in 6 degrees of freedom, resolution half a millimeter accuracy. So we are speaking about good tracking, 120 hertz, in a system that looks like that. I have the magnetic tracking system, I have a table, I have an object that I'm fabricating, the tool, and a control computer. What the tool is doing, I have a CAD design of something that I'm trying to fabricate. If I'm far away, I can do whatever I want. This is a totally manual tool. I can operate in any way that I would like to. I'm getting close to an object, the tool starts to slow down the speed of the beat. I'm going to penetrate the object, the computer stops the beat. So I can now go inside. Okay, this is how it looks like. The LED blink gives me some indication about the distance from the object. However, I have an FSR press button on the tool itself, so I can overwrite. I can decide that I don't want to listen to the computer and I want to switch to a manual mode of operation. Stop, but then I push the button and I can go inside. So the CAD model is mostly a recommendation. I can listen to it, but I don't have to listen to it. On the computer, I have some feedback, visual feedback. So I'm looking at the model that I'm fabricating, and I can see heat map representing the areas that are under risk when I'm working. The green element is the beat. Okay, so this is a little bit data flow. You can skip that. Okay. So this is what this tool allows me to do. I'm taking a CAD model, and then I can do something like that. And believe me, I have no clue how to do something like that without the help of the computer. And it will take me many weeks, many months, many years. I actually really don't know to learn to do something like that. But the tool helped me to be involved in this type of activity without the need or without studying such a craft. However, it still preserves a big amount of personalization and subjective investment, meaning if each of us will do the same process, we will get something a little bit different, and I will speak about it later. But besides just doing this, the tool can do more things. Using the servo, this is an old version of the tool, you can retrace back the shaft. I actually used it a little bit, and then I learned that it's not very useful, because when you're walking and the motor changes the speed, but in the same time the shaft steps back, it's two things that you're trying to track in order to understand where is the model. And it's a bit confusing. It's enough just to slow down the speed of the motor. So I'm not using this anymore, but what I'm using the servos is for autonomous mode of operation. I'm holding a robot in my hand that can do other things to what I'm doing, and I will explain it soon. So considering the interaction with the tool, I divided to 3 different modes. There is a static model mode, meaning there is a model in the computer, and I'm fabricating this model, trying to be as close as possible to the design. There is a computational model mode, meaning the computer reacts. If I'm doing something, the computer proposes a new model. And the last thing, there is autonomous or semi-autonomous, semi-independent mode of operation that the computer or the tool can operate independently of what I'm doing. So I'll present each of these interaction modes. The static one, here. There is a CAD model of the Cybertooth tiger on the computer, and I'm just doing, at the beginning, just investigating a little bit in this block of material. After some time, I start to see the curvature on the manifold represent the back of the tiger, and I start to find this tiger, and I start to develop intuition, and I'm working around the model. So I'm learning a lot about the shape of the model, and I'm getting that. However, I can continue. I can overwrite the computer, push the button, and then do something like that. So I'm penetrating the model, and I'm improvising based on the CAD model, but I'm taking it to a personal place that is mine. This is how the toolpaths look like. The orange color represents when I decided to push the FSR, the press button. This is 1 hour and a half of work. And the blue line and the orange line is what actually a recording of what I did in this time. And I'm sure it is clear that if each of us will do it, we will all get something a little bit different. It's very different than a machine or a robot. If I will do it again, I will get something totally different. And this being rendered directly to the material, to the texture, and to the final object, how it looks like. Materials that I decide to leave, materials that I decide to remove. And this helped me to add my personalization to the CAD or to the digital process. But here we just spoke about static model. The model is static, there is a given model, and I'm fabricating it. I can decide not to do a complete job or to penetrate and to damage it, but the computer will not react. However, there is a dynamic mode, computational mode. So let's assume that this is the CAD model and this is what I fabricated. We don't need to assume this is really what I did. But then I decided to penetrate the model. The computer reacts and propose a new shape by mesh deformation in this example. And then I'm fabricating. I can accept this shape, I can continue this process, or I can say, okay, you know what, I like this, and I'm getting that, and here we have a different example. So there is an investigation of what I'm doing while I am working and about the shape, and when I decided that I'm ready to add the assistant of the computer and when I'm still searching. This I implemented with mesh deformation, but here there is another project I did with a friend, Roy Shilkot, about other approaches. It's not very clear table, but I will try to make it clearer. So in the left area, we see different sketches. I took a block of material, I remove a little bit material, then you see the toolpath, you see the negative space, construction of the computer of the material that I removed, and then a positive space, similar to 3D scanning. So this is a computer model representing that. Now, there is a parametric model in the computer. In this case, I'm trying to fit a cap, and I'm trying to optimize the volume of the cap inside that. So then the computer, after doing that, proposed different shapes of the cap. Okay? So I can, again, I'm doing something, look in the computer, okay, I like the shape, I don't like the shape, let's continue. So there is a conversation between the model and the maker. And this is a similar example, but with different approach. Instead of a parametric model, there is a huge database of position, skeleton position, and I'm just each time trying to fit, to see which skeleton fit best to the volume. So this is the dynamic mode of operation. And then we have the semi-dependent mode of operation. I move the tool from right to left. But I pre-programmed the tool that in the B area, it needs to remove much more material. So while I was moving it, it cleaned this and cleaned that and cleaned that, but I didn't need to move my hand. Okay? One thing that is very useful to use that, it's for texture rendering. For example, there is this teddy bear, and I pre-programmed that in the gray area, I would like that the bit will move back and forth to create something that is more like a fur texture, and in the white area, it will stay smooth. And if we look at the video, at the beginning I will work on the end, and then I will move to the arm. So right now it's quite stable. And then the tool starts to render the texture. So overall, we are speaking about a platform or an infrastructure or a technology that trying to ask what we are doing better and what the computer is doing better. We are doing better in taking creative decisions while we are working, in personalization of the work. So this I'm trying to preserve in digital environment, but I'm not so good in representing complicated 3D structures. I'm not very good in doing detail repetition and stuff like that. And this is what I'm calling the assistant of the machine. And this is a search for a synergy between me as a maker and the machine as an assistive technology in this case. Another application that I did with that, it's when you are working on a craft project and you want to ask for the help of other makers, it's not always easy to give them a chisel and tell, hey, continue. Continue from where? You know what you are trying to do. So you need to sit on a blueprint and to explain and everything like that. But when you have a computer taking control of this collaboration, you don't really care. You can just give the tool to someone and say, continue. The computer will make sure that we are working in the same frame. And this is what happened here. 6 people work on the same relatively very big object to complete this. Here you see each color represents different maker. But there was no need to share information while we are working. And then we were able to add one complete, relatively big artifact. So this is the 3D. This is my current project. And before I will start speaking about other projects, do you have any questions?
Great, thanks. Really fascinating. I really like this approach. It's got some interesting implications. I'm just curious if you considered other, I know there's the feedback you talked about, and you talked about also a screen that perhaps you would also maybe be looking at. What about opportunities to maybe project things onto the surface that you could respond to? I don't know if that would be something you consider distracting or helpful to this process.
This is the main challenge that we have now. This is a good question. I decided, executive decision, I decided at the beginning of the process to put the augmented reality challenge aside, to ignore it, and to focus on developing the milling device itself. But we are aware that this is a big challenge, and there are actually a lot of work that have been done in visualization and craft project projection and goggles and whatever. And now I'm starting to work with a friend that his research will be the visualization aspect, but there is still a lot of work to be done there.
Second question. So the autonomous mode reminds me a bit of another MIT project that's also going on at the same time, Alec Rivers' project, where he has, I think, a router, and there's also an underlying 3D model, but his point is that the router will be much more precise when it's computationally actuated than you could be manually. And it seems like you're taking the opposite approach, kind of the flip side of the coin. Is that
actually
right?
Their approach it's part of something that actually started more than 10 years ago about medical equipment. There are 3D tools for surgery, bone cutting, that make sure that you stay on the path. You are not removing half a millimeter aside. You are just precise where you are. This is fantastic. I'm trying to look a little bit in a different angle of making process, which is about making mistakes, not being precise, taking risk. So I can use the tool, and I actually thought about it at the beginning, before I learned about Alec Rivers' work, to use the actuation of the servos to make sure that we stick to the surface of the object. But then I said, first of all, it's not interesting academically anymore because people have done it. And second, my interest is more about the engagement and the involvement and not about the perfection of the object. I can use the CNC at the end. It will be smoother surface. It will be better. This is not what I'm searching for now.
So, I guess this is sort of related. In this autonomous mode for the texture that you described, seems like really what would be useful would be to have a menu, so to speak, of different autonomous modes or textures or other things that you could think of. But the challenge would be, how do you access those? Kind of the user interface to all these capabilities. And I mean, you could think about having a couple buttons, but have you thought about how you would kind of extend that capability so that the user could be even more interactive and less static model based?
It's a good point, and it's related to the first question, because visualization, for example, I'm searching a different position. Mm-hmm. What about the computer? Tell me, hey, you're very close to this, you're here, you are there, before I'm taking a decision. I mean, visualization is a big challenge, and autonomous mode control is also a big challenge. A lot of work still to be done there.
I guess you could assume that if you had Google Glass or something where you have some overlay, you're looking at the real world interacting with the physical medium, but you have some overlay in your line of view, so you don't have to look off. The problem is looking off to a monitor, right?
Yes.
You'd like it to be right there and have an easy way to access.
But also, the problem with this Google also is that you don't want to use LCD. You want a see-through technology, because we are speaking about craft and about involvement and about looking at the material and touching in it and looking at all the small details that sometimes you lose.
That's why I was thinking something like Google Glasses, where you could overlay. You're still looking at the real physical thing that you're working on, but you'd have the ability to add information to the scene.
Yes.
Okay. Just a quick follow-on question. It's just a part of your question. Do you find yourself ever looking at the screen? Like, was there a screen available for you to look at, or the people who've made this model, right? Is there some kind of pull to peek at what the model is and where you are, or are you fully focused on the physical object?
So the thing, you open a question that actually we are just beginning to think about user study, but there is a lot of discussion about experience. I have a lot of experience using the tool, making almost 15 projects, and some 6 people have experience on working together on this object. So it's really difficult to speak about experience. I can tell you what I'm doing, but it's difficult to generalize it. And I started to be an expert working with the tool. So at the beginning, I put a block of material and I did something, but you don't trust the tool. I think maybe there is a problem, maybe I didn't program it right, because, hey, it doesn't stop me. It doesn't stop me then, because it doesn't stop me because my intuition about 3D object is not as precise as I thought, and I'm making a tiger, but the tiger is actually there, or smaller, or bigger than what I think it needs to be. So at the beginning, I'm not trusting the tool, and what I'm doing, I'm penetrating the block as deep as possible to see if it will stop me. Okay, I arrived to a surface, okay, let's go from this, and okay, I get it. But then when other people start to work on that, each of them had a totally different approach. There was a person that worked like that, slowly one direction all the time, removing material slowly, until he arrived to the arms, and he was happy, hey, I found something. He trusted the tool. The rest of the people were a bit like me. One even complained in the server that I gave, because here we started with a huge block, so he needed to remove a lot of material, and he worked 1 hour and the tool didn't stop him. And he told me the tool is not working. And I actually believed him. I said, maybe we have a problem here, because it was a new tool design. But then after some time, he removed a lot of material from here. And we expected to arrive to the tail, but then there was no tail. At the end, we broke the tail, by the way.
Did they know what they were building?
So there is the visualization, and they are looking at the computer. And at the beginning, you don't trust, so this is related to visualization. Look at the computer, and okay, I get it, I'm far, okay. And there is a lot of back and forth between the computer and what you're doing, and you're not sure, and you're sure. But after you start to, the object reveal itself from the block of material, and you start to see it, you start to forget the computer, because you start to you communicate with the object itself, and you let the object guide you. So you're working on the back, and you arrive here and here and here, and okay, you start to develop intuition, so it becomes to be less digital and more craft. So this was my experience using it. Okay, so I will move to my second project, the Chameleon Guitar. This was my master project in the MIT Media Lab, but right now I'm packing everything in the same PhD, because for me it's sharing similar philosophies, different approach. I like musical instrument. I'm not a professional musician, but I'm doing a lot of projects about musical instrument. And I start work with a maker, violin maker, traditional one, Marco Copiriadi, and he opened a window to a huge board that I was totally different than the place that I'm coming from. This is an instrument that he worked on for like several years. And Marco will never stop working on an instrument if he does not think it's perfect. So I'm asking, when is the deadline? When will it be finished? And I said, it will be finished when it will be good enough. And it's something that I have a problem to understand, because it's like, what do you mean good enough? Can you count it? When? How? What? I don't know. When it will be good enough. And he's like, you see the scratches here? It's a lot of details that he applied on the surface, because he's trying to antique the instrument in respect to the models that he's copying. Can speak a lot about that, but what I care here is the level of engagement and integrity in his work to make something that will be perfect as he sees it. And this is very different than what happened actually in a string instrument in the last 50 years, a shift from acoustic to 70 years, a shift from acoustic to analog electric to digital instrument, even in instruments that like to be very expressive, like violin and guitars. And when you start to have digital guitars, which mean it's a synthesizer that let you manipulate the sound and get any sound that you want, you're also losing something, and you're losing the unique expressivity of the piece of material, let's say a piece of wood. So there are no two guitars that sound the same, acoustic ones, but all the synthesizers sound the same if you're using exactly the same software. And this uniqueness is something important in traditional musical instrument, and I tried in my Chameleon Guitar project to find a platform where I can preserve authentic signature of a piece of material with flexibility and control that we are used to from digital environment. So I designed this Chameleon Guitar. It's a guitar with a replaceable resonator. This is a wooden resonator. You can open the guitar from the back and take it out, like you replace a CD. This resonator has several sensors on the back. I will explain a little bit about the distribution of the sensor. So I'm capturing all the important low-frequency eigenmodes of vibration of this piece of wood, and then I'm constructing a chamber. So it will sound like acoustic chamber made from this material. So you have the software to manipulate and construct this chamber. You can change the size, you can, digital processing, you can do whatever you want there. But the signals are coming from this piece of material and keeping the integrity and the uniqueness of the wood. Some technical details about what's going on here. So the modes of vibration in low frequency in instruments mostly depend on the design of the instrument and the average property of the material. So for example, most of the guitar will have eigenmodes something like that in low frequencies. But when you're going higher and higher and higher, the wavelength is shorter and you're more depend on the locality of the wood. So the distribution of this eigenmode, the pattern, start to look different. If this is the signal coming from a guitar, this is time and amplitude. The tail, what happened most of the time, depend on low frequency, since high frequency decay fast. So this is what we hear most of the time, and this is something that is relatively easy to predict and relatively easy to synthesize. At the beginning, when we just touch the string, we create a lot of non-harmonic, almost chaotic noise. All the frequencies are involved. Then we are leaving the string, and we have all the frequencies decay, the high decay relatively fast to the tail, which is almost a standing wave. This is something that is very, very, very difficult to model, because this really depends on all the properties in all the frequencies. However, for a professional musician, this edge, like in image processing, the edges, the boundaries, are very important for us to get in to carry this information about the sound. And actually, when you analyze sound of instrument, when you cut the transient, the tail is not interesting. Just these several first milliseconds are what is very important. However, for the listener, all of that is not so important. It is important to the player that is doing something and use that the guitar will react in some way. And if it's a synthesizer, the player is doing something and the guitar is not reacting, it's synthetic. It's each time repeating the same type of pattern. You're doing that, you're getting the same response. This is the main problem with digital guitar. And this is what I'm trying to overcome with the Chameleon Guitar. You have a piece of material, piece of wood, cover the back with several sensors. There is a DSP. Low frequencies, I'm trying to manipulate to construct something that will sound like a chamber. High frequency, I'm leaving. Whatever this wood giving me, good. So it's not exactly acoustic guitar, it's not exactly digital guitar, it's some combination trying to keep the integrity of the wood while giving you some manipulation on sound. I will play some examples soon. I made many resonators. Here is just an example. I actually made close to 20. You see a spruce resonator, a cedar resonator, another spruce resonator, a maple, and also some other experimentation. Since we are speaking about an element that is replaceable and relatively small, you can take risk. Things that you are not really doing on a big instrument. Marco, my friend, a violin maker, will not invest half a year making an instrument in materials that he never worked with. It's a lot of investment from his side, but when the things are small, you can take the risk, you can play and manipulate them. It's digital culture. We are used to this type of thing in digital environment. A little bit about the design process. What I actually try to do when I design the guitar is to find a shape for the resonator that allow me or vibrate in the lowest frequency possible. Because since my resonator is small, I'm losing a lot of low frequencies. So I manipulate the shape, and these are the support of this resonator, and I play with them until I found something that was give me relatively low frequencies. The location of the bridge, I will skip that, it's not so interesting. Then I run some laser vibrometry. I scan the vibration of the wood in real time to see how it vibrates. I derivative the surface, and on that, I decided where to locate the sensor. I'm locating piezo sensor, which actually bend derivative of the surface. So I distribute them around the black areas to have a relatively good coverage of the surface. And then I did some DSP manipulation, some IIR filtering, just to compensate this lost to amplify low frequency and to keep them in the system a bit longer to imitate reverberation. And this is how it sounds like. So this is a spruce resonator. This is a cedar resonator. It may not be the best acoustic guitar that you've heard, but I hope you will agree with me that it sounds more like acoustic guitar than like a synthesizer. Okay, And here we have a resonator with 3D printed chamber where I put rice inside. Rice shake while my friend is playing, and you have this physical overdrive. So this is hacking of resonators and opening to much broader DIY discussion. So this is the Chameleon Guitar project. Questions?
Anyone? In the back, just a second.
To what degree do you have do you provide the capability to tweak the effect of the resonator? In other words, the resonator has its effect. You can either saturate it so it completely predominates, or so it's just barely there, or maybe it affects mainly the highs or mainly the lows. From the user point of view, do you give the user much control over the effect of the resonator?
So this guitar, let me. Oh. So this guitar. The design was problematic. I used a DSP board on the back, and to change the algorithm on the DSP was a bit of pain. Now I'm working on a new design that all the processing will happen on max MSP on the computer. So the algorithm will be totally open. You just get in 3-4 signals from the guitar, and actually you do whatever you want with them. You can do what I implemented, but it's open. You just get the contribution of this guitar is mostly the replaceable resonator with the distribution of the sensor. Then you do whatever you want with that. There is no closed protocol.
I mean, theoretically, the user could just bypass the resonator and create their own mental resonator if they wanted to.
Yeah, of course. It's and I present my algorithm, but the algorithm is not the big contribution here. It's not that it's a revolutionary DSP process. It's in my eyes, the contribution is the discussion of this platform or this shape of a guitar that I break it apart for a digital section and an acoustic replaceable section.
So let me flip that question around. You could think of now mechanical interventions that change the properties of the resonator, right? So I saw there was one with holes drilled in, but those could be dynamic over time as well. So you could have a bar that dampens.
This is a spring. I don't have the resonator here, unfortunately, but this is a spring that adds its own reverberation. Here you have screws and a lot of holes, so you can move the screws and change the center of mass. And yes, I think this is a very exciting direction. So you totally physically hack the instrument. It happened today with acoustic instrument, but it happened much less because of the size and the scale and the complexity.
Forgive me for asking this rude question, but why not just build a physical model for the resonator and then just solve it numerically? And what is having the physical mechanical thing there actually buying you? Certainly computationally you could do it, and there's a question whether or not you could come up with a physical model that has the right set of parameters that you're interested in, but so that could be done, I think.
I have two parts of the answer. One is because this is an HCI research, and there is an important to the connection between the material and the aesthetic of the material and the story beyond making this piece of resonator to the sound that it creates and the tangible experience. You can push it with your hand and you change the sound. It absorbs humidity, it changes the sound. The wood is changing, break it. So the story here is important. But I put it aside for a moment. Actually, from the technology point of view, you cannot model it properly. Synthesizers have a lot of problems to do that.
Yeah.
And most of them just copy and paste the transient.
Not true. How many well, we can talk offline.
Personally, I worked 1 year in remodeling transient before I started working on this project in a company similar to Line 6. And we had a big problem remodeling sound coming from one sensor to sound coming from a different sensor, or coming from this piece of wood to a different one, because you don't have all the information that your ears get when you listen to that.
Great. Thanks. I told you I was going to be rude. So.
Mission accomplished. Any other questions?
Okay.
No? Okay.
So the last project, it's more a fun project from my side. This is not an interactive project. It's not an HCI project. I will just start with a story. My wife she's a jewelry maker. She's not doing it anymore, but I met her in the design school. And this is a ring that she designed from silver. But like all her jewelry, she lost it. And she was very sad, and we were sad, and everyone was sad. But we had a picture. So in last birthday, I decided to use this picture and to remodel, and to model it in the computer and to 3D print it in silver. So this is the ring coming back to life. Now, this really represents the risk and the promises about digital fabrication. And the promise is actually clear, but what is the risk? We have that, we have the model. This is carrying a story. She made it took her a week or something like that. This is carrying a story because I made it for her, I work on that and everything. But actually we start to consider, hey, we can reprint it. We can reprint it again and again and sell it. But each time we print it, we divide the story with another physical copy. We print 1 million copies. This does not have a meaning anymore. The only meaning is being carried by the virtual representation, which is, maybe it's okay, but for people like me that really care about the physical identity, the meaning that physical objects are carrying, this is a problem. I would like that this will still be a unique artifact while I'm still using digital fabrication. So how do I overcome this problem? And here I have like 2 or 3 suggestions. This is a project I did like 2 or 3 years ago. I made 3 vases from ceramic, handmade. So this was handmade from ceramic and glaze. This was totally different than that one and from that one. Then I broke 2 of them. The breakage are totally unique. I 3D scan the breakage and I 3D print restoration. This black lattice is a restoration of the vase. You can reprint the black element, but you will have nothing to do with it anymore. It does not carry a meaning. The meaning coming from the physical identity of the breakage. So this is about this marriage between the 2 traditions, this freedom of shape that the black element gives me with the unique identity that the ceramic element carries with it. A little bit different approach is this weaving project. And lately I just finished 4 basketry project, I don't know if it's really a basket, of 3D printed element where I was weaving inside. In this case, we are speaking about canvas, and here it was just a reed. Weaving everything inside in a process that took me almost, in this case, almost 5 days. And it's not perfect, because this is a craft. Yeah? You see that the pattern here is a bit messy. It's very different than the pattern here. And this is part of my investment. You want to have another object like that, you need someone that will weave everything inside. And if I will do it again, I already learned my experience, you will not get exactly the same thing. And again, the object is carrying the meaning from this synergy, this marriage between the 2 traditions. You cannot have this shape in traditional weaving. You need the digital fabrication process to achieve this type of aesthetic, but it's about the 2 living together. So just to summarize, and forgive me if I'm simplifying something, but I'm seeking the combination of risk-taking and involvement with control and with the essence of freedom and progress, and looking for a protocol that allow different traditions. And I presented 3 different projects which are totally different, but they kind of trying to carry a similar meaning or similar philosophy. This I can skip, yeah. So this is it. This is my work. This is what I'm doing. And do you have any more questions?
Great, thank you. Thank you. So questions? A really, really interesting talk. That was fascinating.
Yeah, thanks again. This is that last project, which was a little quick in the explanation, but I don't know how much you've explored it, but it really opens up this idea of promoting some opportunities for reuse of things and sort of kind of different ownership models of objects and re-ownership and reuse. That I don't know. It's like it's a new way of basically promoting that kind of experience that people usually discard things or don't see. I mean, you had a kind of overly emotional story, which I understand for motivating, but it could be for even very mundane objects. They could be put back into use and have this kind of personalization or something. I don't know if that's something you've explored in that particular
I didn't
piece.
explore that, but maybe it's less related, but hopefully it will connect to what you asked. People are asking me, so what are you doing here? Do you develop product? What is it? And usually I'm answering, this is a concept, and hopefully my audience is mostly people like you, is to speak this to research and HCI communities, and I'm not the only one. Many people have started doing it lately, just to say, hey, there are other ways of working, and we should consider it in this type of environment. And I'm not sure my proposal here is the proposal, it's not, but it's about, hey, we should not be so sure that there is one way to go. And yes, all the approach are welcome when we are speaking about deconstruction of dominant paradigm.
Other questions? We're just picking on you today. Adrian in the back.
Yeah, I just wanted to mention that, well, it's your research, but I want to suggest some things you might want to think about for the user study. I'm curious, for example, since there are toys that are based on digging through sand and finding dinosaur bones, and there's paint by numbers, which have a lot of it's a visual boundary, it's a fiducial, but it's still got the same notion that you can spill over the paint. But the question is, you're interested in engagement, and there's a good set of questions about that. My experience with paint by numbers is it put me off painting, because it was really tedious, and I really learned to paint as an adult and found it a very joyful, wonderful thing to do, because I learned the traditional way, not the paint by numbers way. So I'm curious if you can also throw in the question, and this is a hard thing to measure, what are people going to learn in this, which to me, looking at traditional processes, are backwards learning. To start with a digital tool on a CNC machine and a CAD program, and then discover what materials are, is backwards. You can't really do good design paths and picking the right tool unless you've actually driven a router into the material, the particular wood, how damp it is, what the weather is that day. That information comes back through your hands on the router. And so this backwards path, it seems to me you've got to the geometric part, but not the material part in that first tool. So to turn that into a question, I'm just wondering if you see a way to generalize into the material interaction, not just the shape interaction.
So there are some technical problems. We try to work with other materials, and it will just take forever, because the power of the motor that we are using is being determined by not creating too much noise to the magnetic tracking, and also to work with the torque possible with our hand. So we found that we cannot work with two strong motors, meaning we cannot use a lot of materials, and we end with working with this foam. This is a technical problem. It's not a conceptual decision or something like that. But still, even with this uniform, not very interesting material, what I forgot to mention is that when the motor starts to slow down, I'm getting haptic feedback from the material. I'm trying to push the motor inside, and it does not let me go. So I'm starting to learn about the shape of the artifact, of the object, from this type of interaction. And I actually don't really need the LED, or I don't need any other feedback. The feedback is the tangible one, which is one of the surprising and most enjoyable aspect of the experience. But I agree that working with homogeneous, not very interesting material is not the same as working with an interesting piece of wood and changing your decision while you're tracking the grain of the wood and everything. This fascinates me. I love this. This is why I love craft. This tool still problematic for this type of philosophy.
Other questions? One more.
I just have this, I don't have a clear picture yet, but just the idea of having several of these machines at the same time, working on the same piece, several different people. Have you thought of, what sort of permutations you might come up with there?
Yeah, working with this project of the deer, 6 people was working together, and then I interviewed them. One of the people said, "Hey, I couldn't stop thinking about all the other people working together with me at the same time, because there is no technical limitation to do it. Just need to build another tool. That's all." Yeah, so we thought about it. It can be very interesting. You're all the time. Many times I like to speak about this tool as you are dancing together with the robot, with the machine, and on a shared project. Now we are speaking about it's not just me and the machine dancing together. There are other people dancing around us, or other identities dancing there.
In the front.
So cool. I love the work. I think one of the things that's really struck me as interesting is that some of these exemplars can really help us understand what craft practices are. And the strategy you seem to use often seems to be taking sort of traditional notions of craft and trying to reintroduce them in certain ways into digital craft, whatever that is. I'm just kind of curious, with all your explorations in this area, if you see any sort of limitations, essential limitations maybe, to some of these more traditional notions of craft in a digital age. So sort of the never-ending possibilities of automation and control, for example. So if there's anything intrinsic about digital technology maybe that would prevent some of these things from seeping in.
One problem that I always have when I'm presenting my work is, since I'm so enthusiastic or so excited about explaining why craft is important, I forgot to say that actually I don't really care about craft. I'm an engineer, I'm a digital maker, I'm a digital designer, and all the work that I'm doing is to communicate with other makers from my field and to say, hey, I found something interesting in other place, let's consider bringing it here. It's not about craft, it's about us. It's about digital culture. And craft is a good reference and a good source of inspiration. There are a lot of problems, and actually I love digital creation. It's another thing that many times I'm not explaining very well, because I feel that I don't need to protect where I'm coming from. I need to protect something that we are losing, maybe. So yeah, craft has a lot of problems in my eyes, of course, yeah? and a lot of limitation. And there is a reason why I'm not using chisel all the time, and I'm using computer when I'm making things. But this reason, I feel, is kind of obvious to most of us. This freedom, this accessibility, this type of control, but sometimes many of us, including me, are not aware to think that we used to do in a different way, or people are doing it in a different way, and there is a place to consider that.
Anyone else?
Sorry, I'm just going to ask one last question because now you got me thinking about something. So is the 3D, should we think of that as a sort of new hybrid tool that will help introduce others to a craft practice that they'll eventually sort of return to original tools that aren't sort of technologically infused? So it's kind of an educational tool, or is this a new tool for all practitioners to use? Do you see what I'm asking?
I think it's more related to the second suggestion. It's more, it's a concept design. It's an idea that I would like to share, and I would like to create this type of discussion, and I would like that other makers will consider this type of philosophy, criticize it, accept it, whatever. It's just an opening a door for discussion. This is, for me, what is more interesting.
Okay, one more. Good. Awesome. Anyone else? If not, we'll let people get going. But thank you very much.
Thank you. Thank you very much.